Welcome to another video on a blind 75 problem, and in this particular video we're going to solve the minimum window with characters problem. So this problem is again related to the sliding window problems, and we need to basically develop an intuitive understanding of what we need to do here. So if you can look at the screen right now, we're given two strings in this problem. String S. Okay, let me change the color of my pen. So yeah. We have this now, so let's get this out. So we have two strings here. We have string S given to us here and string T. We need to find the lowest substring in this string S that contains all of the characters that are found in the substring T, basically. That's what we need to do in this particular problem. There are two ways we can solve this problem, but we're going to go over both of them one by one. The first method is the brute force method, in which we test every single substring out to find the solution to this problem. And how do we do that basically? So to do that, we need to maintain two things here, two hash maps here. Basically, that's how we're going to maintain our record of finding particular uh, these particular problems. We need to have two hash maps here, and within these hash maps, we need to record these values. So we have x, y, and z. In the string we have here is x, y, and z. So these three characters, we create a hash map for t, which records these three characters. And the occurrence of these three characters is only once, right? So how do we record and manage this particular problem? So in this string here, let me delete these factors here. So in this value here, what we'll do is potentially, let me pull this up, this again, the red color. Yeah. So we have something like this here, as you can see on the screen. Right? This is the entire string we have. The brute force method would be, we'll start off here with an empty string, right? And we'll compare these values. Do we have an x in this empty string? No. Do we have a y? No. Do we have a z? No. So we expand this empty string to include better. So we include O. Now, do you have an X? No. Do you have a Y? No. Do you have a Z? No. We expand it one more. Do you have an X, Y, Z? No. So we expand it once more. We have a Z here. So we go here and say, yeah, we have one Z in this problem now. So if that's the case, now we continue moving because again, we don't have all of these here. And how do we check those conditions? So there's another important factor here. We compare these hash maps and their values with this operator here. As you can see on the screen, this is the operator that is going to be used in the brute force method. We need to check if the value of x, y, and z in the window hash map is less than equal to the value in the count hash map, right? That's what we need to do. So we move forward one by one. There's O again. No, that isn't it. There's D again. No. There's Y now. Yeah, Y is there. So we add another one here on Y. So we meet two conditions here, right? But we're still not meeting all of the conditions. Then we have X here. Yep, that meets our condition. So we have one X here. So then we record basically all of this as between index 0 to index index 0 to 6. That is where we with the length of 7, that we record that this substring basically meets our requirement. But this is a very, very difficult method to sort out because how do we check the other portions here, right? The other aspects here. And then how do we find the lowest substring, which is something that we need to find in this problem? All of this would require a lot of technical or difficult coding. but a more simpler and more efficient manner. Let me clear the screen, and we work on the not so brute force method for this problem next. So in this case here, we'll build two additional aspects to this problem, right? We'll build total amounts here between on top of these hash maps, right? Which record the total values that that we have, the total count here, right? And the total count is going to depend on here it's going to always be 3. So we just compare the total counts among each other in this case. And when the total counts are compared, when both the total counts are 3, that's when we have our substring, basically. That's how we're going to solve this problem. So to do that, we simply have, presumably, let me change the color so that parent. So supposedly we have this string here, right? This is the first string we found, which has these values. We have x, y, all of the value of x, y, and z is 1 here. Value of x, y, and z on all 3 is 1, and our total count becomes 1 as 3 as well. And both of these values are equal, so we again store the value of 0 to 6 with a length of 7 as our the length of 7 as our substring. We need to find the substring with the lowest value, so we're going to record the frequency in frequency and check all substrings that we develop and see if we can find one with a lesser length than 7, right? But once we reach the point where we see that we have all of our strings, then what we can do is we can start pulling back from the left side. We can reduce our sliding window and exclude O and move it here, this section here, right? Now, though, we we still have all those values. We remove U as well and bring it here. We still have all of those values, and the string is shorter, so we're going to write strings with shorter length. So again, we have we should have written 2 strings. So one would be 126, right? And the other would be 226, right? We had developed these 2 strings as well as we checked, and the length, let's just keep it as let's just presume I'm just right. 6 and 5. And in this case, this one is wiped from the memory, and in the second case, this is wiped from the memory as well. We found shorter strings, right? But still, we need to continue exploring. So again, we say remove Z next, and we bring the sliding window here. But here, hang on, here the problem arises. So here our Z becomes 0, and our count here also becomes 2. So it's not equal anymore. In this case, we move our sliding window forward. A doesn't change anything. We still have 0 count of Z. One step again, we get a Z again. Z becomes 1 again. Count here becomes 3 again. Again, test it out again. So it starts from 3 to 3 to 8, right? And the length is it's 6. It's not shorter than our existing one, so we don't add this in our list. So, but again, we have all the count is all 1 again, so we remove the O from the list and bring the sliding window forward. We have D. Still have all the count is still 1. We remove D and we move to Y. Now our window is 1, 2, 3, 4, right? So we have our window is from 0, 1, 2, 3, 4, 5, 6, 7, 8, 5 to 8. That's our new window, which has a length of 5 to 8, which has a length of, let's say, 1, 2, 3, 4, which is a length of 4, right? We cut this out from memory. This is a shorter string that we have now. Now that we have this shorter string, right, we have these values again. We have still one more value. So we extend this by, we remove y. And now our string is, we can't find a substring again because y is 0. And our value of total becomes 0, 2 again, not equal. So we increase it to v, still no change. After v, there's nothing, which means we're done. And this is the shortest string we can identify. This is the proper algorithm that we're going to use to solve this problem, right? This is the logic behind it. And this algorithm works in the time of O of n. And why is that? Because every single value in this, we go over only. As we're moving here in the sliding window, you've noticed we didn't repeat any value more than once. So because of that, because of every single value being only 1 here, it has pretty much made our time complexity O of n, which is the ideal time complexity we need for this particular project. With that, let's start coding this problem out. So again, before we push forward, we're going to go over 4 things that we need to do here. We need to have 2 pointers with sliding window. We need to do a corrector frequency count. Then we need to minimize the window as we move from the right or the left, depending on the situation. And then we need to consider the edge cases where the strings given in the characters given in T are not present in S. So we return an empty string. Or if T is longer than S, it's impossible to find such a window, so we also drop that out. So those are the 2 edge cases we might want to consider, right? So to start off, we'll first, first confirm if T or S are there or not. So let's sort that out. Now that we have dealt with one of the edge cases, then we need to basically create a dictionary to store the frequency of characters in T. So we'll set that up. Using the counter function that we imported at the top here from the collections library to count the occurrences of T within the library. Then we basically need to number the unique characters in T to be found in the window. So we need to now further understand how many unique characters are there in the T. Then we need to start our left and right pointers so that we have our sliding window sorted out. Then the next thing is we need to create a dictionary and keep tracks of the character counts that we find or the substrings character counts that we have. So we need to set that up. The next thing we need to do is basically understand how many unique characters are in T currently in the window with the uh, desired frequency, and we need to track that. Next thing for us to do is basically set the result up in a tuple format with which would have window length, left, and right as the format. Let me just get that sorted out on the comments as well. In this tuple format, we track three things: window length, left, and right. That's how a tuple would look, which would contain these results. Now, setting that up basically would be our format below. Set up a floating point at infinity at the start, and this tuple values would change as we move forward. So we're just setting these values up. That's out of the way. Now we need to work on our while loop, which basically is our window logic that would basically run this entire piece of code. To do that, we'll set up the while loop first, and the exit condition will be as soon as we exceed the length as we just showed in the window. As soon as the right pointer exceeds the length of the window, that's when the program should stop running. After that, we need to add the current characters to the window first. So basically, our character, whatever character would be on the right pointer, would be added first in the window count, and that is what we need to do. Using the dot get function here to get certain values. Next is we need to check if the current character matches the required frequency in T. To do that, we do an if statement to see if the character is in the dictionary we created for T, and the window count char is equal to that particular char in dict T. So we need to set that up, and then we add count to formed variable. We have that out of the way. The next logic that we need to write and code out is to contract the window until it ceases to be desirable from the left side. So now we need to work on the left side, as we showed that logic during our explanation. Within this particular while loop, we need to save the smallest window until now. So we need to set up the if statement logic in regards to that. Right minus left plus 1, and then we add the other two characters within our basically saving around updating the values in the answer tuple by putting these answers based on the smallest window that we have found up till now. So we're going to be writing that out. That out of the way, the next thing within this same while loop we need to do is basically the character position at left is no longer part. We need to make sure the character position at the left should no longer remain part of the window. So we need to forward and set everything up. Next, we're checking if char is in dict t and window counts is less than dict t char, and then we deduct one from the formed variable. In that if window, we remove the one from the formed variable. Then we need to move the left pointer ahead. So we add one to the left variable. Then we move out of this particular while loop and move the right pointer to the left. And then we move out of the while loop, this while loop, to return the value back to the main function. This return statement, we're going to return an empty string if answer is equals to infinity, else we're going to return the particular answer. With that, let's run this code and see if we're able to solve this problem. So we have a syntax error. Window counts is not defined. Let's go back to the top where we defined. Yep. So we need to set that variable name properly. Let's run this case code again. And all three of our test cases clear. So basically, that's how you solve this minimum window with characters problem. The important part is that the code is not important. Have multiple ways you can write this code. You need to understand the logic behind this particular question, how we framed the solution, how the optimized logic works, then apply that optimized logic within the. With that, we will wrap this video up. If you got any value from this video, please like and subscribe. And if you have any questions, any queries at all regarding programming, coding, so on and so forth, please comment below and let us know. With that, we will wrap this video up and we'll see you in our next video. Thank you.